Section 8.2 is about special right triangles. So that means that you either have a 45, 45, 90 triangle or you're going to have 30, 60, 90 triangle. And so when I'm saying those numbers, I'm talking about the angle measurements that are within those triangles. So the first one we're going to do is the 45, 45, 90. What you can do is you can find the lengths of the sides based off what kind of triangle it is. So for this first one, it's showing you that if you have a right triangle and the other two angles are 45, 45, you know that these two sides are going to be the same because this is going to be an isosceles triangle. If you want to find the hypotenuse, you take those legs and take it times the square root of 2. So the first problems are just going to be practicing using those formulas. So on letter A, I see that I have a 45, 45, 90 triangle. So my theorem or my formula says to do the hypotenuse equal to the square root of 2 times the leg. So just plugging in, I could put 9 in for my leg spot and then just simplify. So for part A, I would find that it would be 9 square roots of 2. So then letter B, I see that I also have a 45, 45, 90 triangle, but this time my leg is 2 square roots of 2. So when I plug it in, I have the square root of 2 times 2 square roots of 2. I have to do some simplifying by timesing those radicals. So I would end up getting 2 square roots of 4, and then simplifying the square root of 4, so I would get 2 times 2 as a whole number, and then timesing those end up with 4. Alright, pause the video and see if you can do the got it question. In the got it question, it gives me the leg, which is 5 square roots of 3, so I would take that times the square root of 2 to find my hypotenuse. I would times my like terms, which are the radicals, so I would get 5 square roots of 6. Square root of 6 will not simplify because there are no perfect squares that go into it, so that would be my answer. Alright, let's take a look at the next question here. So on the next question, they still give me a 45, 45, 90 triangle, but now they are giving me a hypotenuse. So the formula will not change, but how you solve it might look a little different. So here is my formula, and then I would plug in 6 for the hypotenuse, so I would have 6 equaling the square root of 2 times the leg. In order to get the leg by itself, I need to divide both sides by square root of 2. So on this side, the square roots of 2 cancel each out. Then I have 6 over the square root of 2. Remember when you were simplifying radicals that you had to rationalize the denominator, which means you can't have a radical in the denominator. So I would times the top and the bottom of that fraction by the square root of 2. I would times straight across, and I would get 6 square root of 2 on top. Timesing these radicals would give me square root of 4. Then I would simplify the square root of 4 and get 2 in the denominator, and then 6 square roots of 2 still on top. Then I would want to reduce this 6 over 2 and get 3 square roots of 2. So the only difference is there's a little bit more simplifying to do when they give you the hypotenuse versus the leg in that kind of triangle. Alright, pause the video and see if you can do the got it question. In the got it question, I have the hypotenuse, which is 10, so I set 10 equaling the square root of 2 times the leg. I divided both sides by the square root of 2. This side, the square root of 2 is canceled. Then I needed to rationalize the denominator, so I times the top and bottom by square root of 2. That gives me 10 square roots of 2 on top, and then timesing the bottom gives me square root of 4. I can simplify the square root of 4 and get just 2. And then I would need to reduce these whole numbers, so 10 divided by 2 would give me 5 square roots of 2. Okay, so the next one is an application problem, so why don't you pause the video and see if you can get it set up. Okay, so in problem 3, they gave you a softball diamond, and it's telling you that it's a square, so I drew out this picture with my right angle in there and then put the 45s in there. So then I see that I'm trying to find the hypotenuse given the leg. So all I need to do is just put 60 in the leg spot, take it times the square root of 2, and get an answer of 60 square roots of 2. Okay, the other kind of triangle that is special for a right triangle would be a 30, 60, 90. Now this one, it has a little bit different formulas just because since these angles are not the same, all of the side lengths will be different. So notice that opposite of your small angle would be the short leg. opposite of the 60 angle would be the longer leg, and then opposite my hypotenuse obviously is that piece. So it says if I want the hypotenuse, I have to take 2 times my shorter leg. So you must have the shorter leg to find the hypotenuse. Then it says if I want to find the longer leg, I take the shorter leg times the square root of 3. Alright, let's see what that looks like here. So in problem 4, I see I have a 30, 60, 90 triangle. So then the next thing I do is analyze what they are giving me. They are wanting me to find D, which ends up being the short leg, and they are giving me currently the long leg. So I look up here at my formula. It says long leg equaling the square root of 3 times the short leg. So then I can plug in 5 for the long leg. So I would have 5 equaling the square root of 3 times the short leg. Then I would need to divide both sides by the square root of 3. I would need to rationalize my denominator, so I would times the top and bottom by square root of 3. That would simplify to 5 square roots of 3 over the square root of 9, and then simplify that denominator again, so I would get 5 square root of 3 over 3. 5 over 3 doesn't reduce, so that would be my answer. Pause the video and see if you can do the got it question. So in the got it question, it's wanting me to find f, which is the hypotenuse. So my formula for that was take the hypotenuse and equaling it to 2 times my shorter leg. Well, I just found the shorter leg in the previous problem, so I just have to do 2 times that answer. So when I do that, you can put 2 over 1 and just times straight across. So that means you times like terms, so 2 times 5 is 10, square root of 3 does not change, and then 1 times 3 on the bottom is just 3. 10/3 will not reduce, so that's why it just stays as that answer. Okay, one more question here. Why don't you pause it and see if you can get it set up, and then come back to it and see how I did it. So in this problem, they gave you a 30, 60, 90 triangle, and how I know that is because if this is my height, it's going to bisect this angle. If I have an equilateral triangle, that means this angle is 60, so if it's bisected, this angle ends up being 30. So then my other angle here would be 60 right there. So the reason that's helpful is so that I know which side that they're giving me, so that 18 ends up being the longer side. So they're wanting me to find the hypotenuse. Okay, if they're giving me the longer leg, I have to work backwards to find the shorter leg, because in order to find the hypotenuse, I need the shorter leg. So you actually have to use both formulas in order to solve this. So I started by doing 18, which is the long leg, equaling square root of 3 times the short leg. Then I divided both sides by the square root of 3. Then I rationalized the denominator, so I times the top and bottom by square root of 3. Then I simplified, so I got 18 square roots of 3 over square root of 9, and then simplified again and got 18 square roots of 3 over 3, and then reduced 18 over 3 and got 6 square roots of 3. So all of that work was just to find the shorter leg. Now you need to come back and find the hypotenuse, because that's what they're actually looking for. So now I would have to take my shorter leg and times it by 2 according to the formula. So now I times my like terms and I get 12 square roots of 3. So just be aware that when they're giving you the longer leg and they're asking you to find the hypotenuse, you do have to use both formulas and follow suit in order to find it. Okay, so this lesson has 2 main points, 30, 60, 90 triangles and 45, 45, 90 triangles.